Welcome in Dark Core. Saturn has always amazed us with its rings and storms, but the James Webb Space Telescope just revealed something no one expected. In late 2024, Webb spotted mysterious dark beads in Saturn's auroras and a strange star-shaped pattern below, features never seen on any planet, and they are raising big new questions. In this video, we'll break down Webb's observations, what scientists think may be happening, and why it once again challenges our understanding of planetary atmospheres. The discovery. On November 29, 2024, an international team of 23 scientists used Webb's Near-Infrared Spectrograph, or NIRSpec, to observe Saturn continuously for 10 hours. Their goal was straightforward, to map emissions from two atmospheric layers at the same time. The first target was the ionosphere, roughly 1,100 kilometers above its visible clouds, where hydrogen molecules form charged ions known as H3+. These ions glow faintly in the infrared, making them an ideal tracer of auroral activity. The second target was the stratosphere, about 500 kilometers lower, where methane dominates the chemistry. The results were unlike anything researchers expected. In the ionosphere, it revealed dark bead-like patches scattered through its northern aurora. These beads were stable for hours but slowly drifted over time, showing they were real features, not random noise. Meanwhile, in the stratosphere below, Webb detected an asymmetric structure, a star-like pattern with four arms radiating from the pole. Unlike its well-known hexagon, which is six-sided and persistent, this star was uneven and lopsided, reaching toward the equator in irregular arcs. When scientists compared the two layers, the darkest beads in the aurora seemed to align with the strongest arm of the star-shaped feature. The alignment suggested that processes in Saturn's upper atmosphere might be linked vertically across hundreds of kilometers. No telescope before it had the sensitivity to capture this. Ground-based observatories were blocked by Earth's atmosphere, and Cassini lacked the right instruments. This was the first time its ionosphere and stratosphere had been mapped simultaneously with such detail. Instead of broad, uniform emissions, it revealed fine-scale patterns that nobody predicted. For planetary scientists, it was a reminder that Saturn is more complex and dynamic than models had assumed. Scientific importance and theories. The findings matter because they challenge long-held assumptions about gas giant atmospheres. For years, scientists viewed Saturn's upper layers as relatively smooth and featureless, shaped mainly by large-scale circulation and auroral energy. Webb has shown otherwise. The dark beads may be signs of localized interactions between its magnetosphere and its atmosphere. The planet's strong magnetic field funnels charged particles along field lines into the poles, powering auroras. Where those interactions vary in intensity, they could carve out bead-like gaps or patches in the ionosphere's glow. Another possibility is turbulence or instabilities forming naturally as it rotates, producing structures that drift slowly around the pole. The star-shaped pattern in the stratosphere is more mysterious. It does not fit the symmetry of the hexagon but appears in the same region. Some researchers suggest it may be the imprint of atmospheric waves propagating through the stratosphere. Others suspect it reflects changes tied to its seasons. The planet was near equinox when the data were collected, a time when circulation patterns undergo major shifts. The apparent alignment between beads and star arms is the most intriguing element. If the two layers are connected, it would mean energy or motion is moving vertically through them, linking the ionosphere to the stratosphere. That would be unprecedented. On Earth, the upper and lower atmospheric layers do influence each other, but not in such a clear geometric pattern. The discovery is also a technical milestone. By observing both layers at once, Webb provided a multi-level picture of them. This ability to detect subtle features that other telescopes could not is what makes the discovery so significant. It shows that giant planets may hide fine-scale dynamics invisible until now. Many questions remain: are these features permanent, seasonal, or unique to Saturn? What's clear is that they challenge how scientists understand giant planet atmospheres. Implications and what's next? The implications extend beyond Saturn. If bead-like and star-shaped features exist in its atmosphere, it raises the possibility that Jupiter, Uranus, and Neptune could harbor similar phenomena. Each has its own magnetic field and auroral processes, and it could reveal whether they too hold hidden patterns in their upper layers. For Saturn itself, the findings may shed new light on the iconic North Polar hexagon. The hexagon is a stable, deep feature of the planet, but the discovery of overlying beads and a star pattern suggests that upper and lower layers might be linked. The alignment between features hints at a column of dynamics stretching through them, connecting the auroras, stratosphere, and deeper storms. If true, this would redefine how we view the hexagon, not as an isolated surface storm, but as part of a larger system. The timing of Webb's observations makes follow-up especially valuable. Saturn is transitioning into northern autumn, meaning the North Pole will receive less sunlight in the coming years. Seasonal changes can reshape circulation in both the stratosphere and ionosphere, potentially altering or erasing the features Webb observed. By monitoring it across its seasons, scientists can determine whether the beads and star arms are long-term structures or temporary responses to changing sunlight. This also underscores the importance of continued Webb time for planetary science. While designed primarily for deep space astronomy, it has already proven transformative for studies of our own solar system. Tracking these features over the coming years will reveal whether they are stable, evolving, or transient. Webb's discoveries will guide future missions with new spacecraft needed to probe Saturn's atmosphere more deeply than Cassini could. This discovery reminds us that even though Saturn has been observed for centuries, it still hides surprises, proof there's much more to learn about our solar system's giants. Outro. Webb has revealed Saturn's atmosphere is far more complex than expected, with strange beads and a lopsided star pattern hinting at unseen connections. The puzzle is only beginning, and we'll be watching closely as scientists work to solve it. Stay tuned for more discoveries. Thanks for watching Dark Core.